Hello, everyone, and welcome to our virtual Triangle SciTech Expo with the North Carolina Museum of Natural Sciences. My name is Nancy, and I will be your host for this upcoming program, and it's called Science Takes Flight in Antarctica, with a tribute to an Antarctic pioneer from North Carolina. And with me is Thomas Henderson. He's the producer and director of Ice Eagles, and we also have Lieutenant Commander Robert J. Tuttle from the US Navy joining with us. And they will be sharing some historical moments. But before we can do that, since we do have some participants in YouTube and in Zoom, I'm going to give a quick Zoom tutorial. So I'm going to share my screen real quick. There you go. So just I want to start by saying that closed captioning is available both in YouTube and in Zoom. If you are in Zoom, just click on that little CC button at the bottom and then click on Show Subtitles. You can also change the settings there as well. If you are in gallery view, all the boxes of the guests and the speakers will obscure your slideshow. So what we recommend is that you actually click and select speaker view. If you do that, then the speaker box will get next to your slideshow. You also have to select the downward arrow on the view options and then click on the side-by-side mode. So that little box, the speaker box, you can make that bigger or smaller just by sliding that slide bar either to the left or to the right. And then last but not least, we do want to hear from you. So we do have chat options available both in YouTube and in Zoom. And so for Zoom, you just have to click on the chat box. And then you can put all your comments there or your questions for Robert and for Thomas. We are gonna wait until the end, for those questions to be answered. But we do have Skelly. He's gonna be our moderator, so he's gonna be looking at that chat. And so to get the chat started, we thought we would ask you an icebreaker question. And it's like, imagine if you are assigned to join a mission to Antarctica. What non-essential object would you bring with to stop sharing? And I'm gonna actually give the word to our speakers right now. So Thomas and Robert, welcome. We're so excited to have you with us today.
Thank you.
I'm gonna stop my spotlight, and then if you want to start sharing your presentation, you can go ahead. Thank you. Because I believe that you are going to talk a little bit about yourselves as well, right?
Yes.
Awesome.
I can start off while Tom's getting it ready.
Yeah.
Can you see that?
Not yet. But Robert, if you want to start talking, meanwhile, Thomas can pull up his presentation.
Okay. Hello, my name is Lieutenant Commander Robert Tuttle, U.S. Navy, retired. I was a polar aircraft commander flying ski-equipped LC-130 cargo planes in Antarctica from 1983 to 1986. My crew and I flew science teams and equipment all over the continent of Antarctica to support science. Tom Henderson spent 3 seasons in Antarctica as a cartographer and a marine technician. He's also produced and directed the documentary Ice Eagles, American Aviation in Antarctica. He will be discussing science projects in Antarctica and the way aviation has supported science in Antarctica over the years. Finally, we'll be discussing an Antarctic pioneer from North Carolina named Lieutenant Commander Conrad Gustin, who made the first landing of an airplane at the South Pole in 1956. Okay, this is a picture of me returning home to our base in California after my last season flying on the ice. I was gone so long, my young daughter is looking at me thinking, who is this guy holding me? In the 1980s, we had no FaceTime, Zoom, or emails with our family while we were in Antarctica.
Yeah, this is Tom Henderson. This is a picture of me at Amundsen Scott South Pole Station in 1982. We were preparing the skiway for the opening flight, which would be our first contact with the outside world for 8 months. The temperature was minus 60 degrees Fahrenheit. I developed a great admiration and appreciation for the pilots who flew us around in Antarctica to carry out my work as a US Geological Surveyor cartographer. That became the seed idea for my film Ice Eagles, which was released in 2018. There's an enormous amount of science going on in Antarctica right now, perhaps 10 times more than when Rob and I were there. Here are just a few examples of research being done. Begun in 2003, the West Antarctica Ice Sheet Divide Project is drilling a series of ice cores more than 2 miles into the ice cap. The ice serves as a sort of time capsule for past climate, allowing scientists to understand how abrupt changes in the climate unfolded tens of thousands of years ago. This is a look inside of an enclosure where one of the ice drills is at work. Volcanology is one of the geological disciplines at work in Antarctica. In this video, flyby of Mount Erebus on Ross Island from a New York Air National Guard LC-130 Hercules plane, you get a good view into the crater, the only active volcano in Antarctica. Helicopters, which you see on the right side of this photo, ferry scientists to the volcano to retrieve instrument data and investigate the mountain. Here, a scientist controls the Yeti, a four-wheeled robot that carries ground-penetrating radar on the edges of the slopes of Mount Erebus. The Yeti is scanning over an ice cave created by the heat and gases vented by the volcano through fissures. This is an artist's conception of the scientific research being conducted on the Antarctic Gamburtsev Mountains under the ice. A network of seismic instruments was established across an area the size of Texas, and then an airplane interfaced with these instruments was able to define the topography of the land underneath the ice. A US-led international team of scientists has verified that the existence of a mountain range that is suspected of having caused the massive East Antarctica ice sheet to form. It also has created a detailed picture of the rugged landscape buried under more than 4 kilometers or 2.5 miles of ice. The Waddell seals have been studied for decades. The seals can dive over 2,000 feet and can stay underwater for more than 80 minutes. Born in October during the austral spring, these pups will spend about a month nursing and learning to swim from their mothers, and then strike out on their own. The pups increase their weight by 100 pounds each week during the short Antarctic summer to be able to survive the long winter. Each research year, at least several new species are discovered in Antarctica. This translucent ice fish is one of the strange varieties of fish discovered there. In the summer season just completed, the Australian researchers used a new sensing technology to map huge swarms of Antarctic krill, a shrimp-like crustacean that is one of the basic building blocks of the Antarctic food chain. This 3D graphic shows a swarm composed of millions of individual krill. You can get an idea of the size of the swarm from the ship that's in the upper left corner. The Milky Way and the Aurora Australis shine above the night sky near McMurdo Station. Antarctica is an ideal place for scientists to study the aurora because of the incredibly clear atmosphere there. This instrument payload will circle the continent on a balloon, listening for radio signals made when a neutrino strikes a nucleus of a water molecule. The balloon carrying the instruments launches from the Long Duration Balloon Facility located on the McMurdo Ice Shelf and is used to launch scientific experiments more than 100,000 feet into the stratosphere above Antarctica. There, they catch a ride on the polar vortex, a stable upper atmospheric current that circles the continent. 3/4 of a mile from the South Pole lie some of the Earth's most powerful telescopes. Operated all year round, they are engaged in one of the great scientific quests of our time, scanning the skies for ripples in space and time from the early universe. Located in the middle of a polar desert at more than 9,000 feet elevation, the thin, dry air of the South Pole results in some of the best astronomical observing conditions on the planet, especially during its 6 months of winter darkness. All of these telescopes capture light in the microwave portion of the electromagnetic spectrum. Two towers flank the IceCube Neutrino Observatory at South Pole. Cables attached to strings of instruments buried in the ice below enter the two metal towers and then into the building. IceCube uses thousands of instruments buried in the ice in an array thousands of feet deep to record information about neutrinos, the nearly massless particles that provide clues to high energy cosmic events in the universe. This is a diagram of the IceCube sensor array under the snow at pole. IceCube is composed of 86 cables, each holding 60 digital optical modules. And the building that you saw in the previous slide is in the diagram in the upper right to give you an idea of the scale.
All right, most of these examples of science in Antarctica depend on aviation for support, either in transporting people or the cargo and equipment needed to support those people in their work. However, flying in Antarctica is extremely dangerous. Why? There are many reasons. First, Antarctica is huge. Here you see the continent in relation to the size of the continental United States. Fuel supplies in Antarctic bases are few and far between, so careful planning is required to make sure you don't run out of fuel in the world's harshest environment. This map shows a flight path from the U.S. Antarctic Program Support Base in Christchurch, New Zealand, to McMurdo Station, the main U.S. Antarctic base. The flight is over the coldest and stormiest ocean in the world, the Southern Ocean. The planes making this trip do not have enough fuel to fly all the way to Antarctica and then return to New Zealand if the weather gets bad. Therefore, there is a point of safe return, PSR, on the flight down to Antarctica, where once past this point, the flight has to continue to McMurdo regardless of the weather down there. The weather in Antarctica can be extreme. Winds can reach 200 miles an hour. Storms can often last for days and sometimes weeks. Temperatures in the summer can plunge to well below freezing. Flying and working in these conditions is challenging for both people and aircraft. This picture shows the difficulty when you have no visible horizon and no surface definition, and when everything in the background is white, including the mountains. Many aircraft accidents have occurred due to the poor visibility conditions over the years. On overcast days or when the wind is blowing the snow around, it gets extremely dangerous. In the worst case scenario, you can fly into whiteout conditions and may have to land on your skis in zero visibility conditions using your instruments only. Here is a case where that was not done successfully.
LC-130 number 917 was on a routine resupply run to South Pole Station in January 1973. Loadmaster David Hazard, who survived the crash of Super Constellation Pegasus in 1970, was on board.
So I took 22,500 pounds of cargo with me. For some reason, that day, I put two 25,000-pound bridles on the front of my cargo instead of just the normal one. The outer markers at pole station are 55-gallon drums painted black. Now, I was looking out the little window, seeing a black one go by, and I heard the co-pilot tell the pilot, outer markers in sight, go visual. Well, he went visual, and he had a whiteout. Well, when we hit the ground, the rear skis went into the snow and ice about 3 feet. When we came out of the hole, the wings broke off. When the wings hit each other, the fuel engulfed. The center escape hatch blew down, and it looked like Dante's Inferno in there, all orange ash and everything. And all I could think of is we were going to be a Roman candle because I had 1,500 gallons of mow gas in the back. The tail section broke loose. The main landing gear came off. The nose gear collapsed, and we slid for 1,800 feet. When we came to a stop, I had to tell the passengers to grab their gear, and the Coast Guardman says to me, he says, geez, that was a rough landing. I says, well, we crashed. So we all got out. Nobody got hurt. The cargo didn't move. Yeah, they had a message go out to the world on that account that the professionalism of the loadmaster did save lives. So we were taught to tie everything down to make sure it wasn't going to go anywhere.
Many fatal or near fatal aircraft accidents have occurred due to poor visibility over the years. In this next example, this was compounded by poor mapping in the area.
During Deep Freeze 61, the R4Ds were still a part of Operation Deep Freeze. John Barrett boarded R4D Semper Shaftus on November 22, 1960, for an exploratory flight from Byrd Station. They flew north in heavy overcast and poor visibility. The navigational chart they were using showed a clear path, but they were on a collision course with the uncharted Prairie Mountains.
Aircraft commander grabbed the yoke and started to push, yelling, "Get the nose down!" And he tried to, was just reaching for the throttles to cut the power so that when we crashed, we might not burn. He figured the three of us in front were going to be killed. We'd go right through the windshield.
We were rocking back and forth, and you could see rocks out one of the windows on the side.
Plane captain and the pilot thought we had hit something with all the shuddering. The whole plane was shaking. We tried to go through a 10,000-foot pass flying at 9,000 feet was our basic problem.
Everybody decided, why don't we just go the heck back to Byrd?
Inspection of the aircraft verified they had damaged the wingtip. The margin of survival was literally inches.
The ice surface there is crisscrossed with crevasses. These are always a hazard when working in the field. Landing areas must be carefully assessed from all directions on a clear weather day before the initial landing attempt is made. Here is an example where a ski-equipped LC-130 accidentally found one of those hidden crevasses. This type of accident also happened while I was flying down there, but we brought in a maintenance team and repaired and recovered the aircraft. Navigation is a special challenge in Antarctica because magnetic compasses are practically useless there. That is because the South Geomagnetic Pole is hundreds of miles from the geographic South Pole. We used inertial navigation systems, radar fixes off the terrain, and sextant shots to help us navigate back in the 1980s. Remember, there was no operational GPS system back then. The grid navigation system in Antarctica was created to deal with the magnetic compass issue and with the difficulty of navigating by latitude and longitude. Position is difficult to compute because all the lines of longitude converge at the pole. At the geographic South Pole, all directions are north. A grid is aligned with the map of Antarctica as shown. Notice to get from McMurdo to the South Pole, you head northwest on the flight station instruments using the inertial navigation system using grid nav. That is very confusing for passengers that were visiting the flight station, and I would tell them to talk to the navigator for an explanation.
The practical use of flight in Antarctica began with Admiral Richard E. Byrd. Admiral Byrd led the first American expedition to Antarctica in 1928 to 30. His large camp there, called Little America, was established to explore the region and conduct science, but his central goal was to make the first flight over the geographic South Pole.
The date was November 29, 1929. A few months before the expedition was to depart, Chief Pilot Floyd Bennett died of pneumonia. Byrd had brought a stone from Floyd Bennett's grave to Antarctica specifically for this moment. He wrapped the stone in a small American flag and dropped it over the point he had calculated as the geographic South Pole. They were elated at having achieved the primary goal of the expedition.
Byrd continued to expand the use of aviation in Antarctica in his 1933 to 35 expedition and in subsequent expeditions. This is an example of the support of science using a Curtiss Wright Condor biplane.
The fixed-wing aircraft were heavily used in the 1934-35 summer season. Planes were used to support a network of seismic shocks. Dynamite charges were set off underneath the ice surface while instruments recorded the time it took for sound waves from the blast to bounce off the land below and return. Knowing the speed of sound, the time delay could be converted to a measure of ice thickness.
The International Geophysical Year of 1957 to 58 was a watershed event for science in Antarctica.
After World War II, scientists across the globe returned to their quest for knowledge of the physical world. By the 1950s, the technologies existed to greatly improve the gathering of scientific data in remote regions of the world. International coordination and planning began in 1952 for a major scientific investigation of the planet in spite of the Cold War.
The IGY was the International Geophysical Year. It was an 18-month period, actually, from July 1st, 1957 through the end, December 31st of 1958. During that time, scientists of 66 countries went out to try to understand the physical Earth. Of those countries, 12 of them had scientific stations on the Antarctic continent or the sub-Antarctic regions.
Let's open up Antarctica. Let's provide fantastic logistics to the scientists so they can actually work and save the planet if necessary. Let's find out what's going on.
And scientists like Berkner and Lawrence Gould, who is the chair of our Antarctic Committee, would go to Congress and say, well, we need X million dollars for this one-shot thing, but boy, it's going to be great and we should support it. Oh, and by the way, those Soviets, they are planning a very big, very ambitious program. And so, we don't want to be second best to them, do we? Oh, well, yes. How much do you need? How much would you like? Is that enough?
The Navy's involvement was staggeringly stupendous in its the amount of money spent, the personnel, the fantastic drive, the achievements of the Navy, US Navy in providing the airplanes that went down, in providing logistics to the scientists. Incredible.
The US Navy Construction Battalion, the Seabees, provided the logistical support for constructing and maintaining the 7 US bases in Antarctica during the IGY. All of the bases were supported, at least in part, by aviation. Supplies to build the main US station at McMurdo on Ross Island were transported by ship, tractor sleds, and by aircraft. The Seabees began construction of McMurdo in late 1955. Using Quonset huts and prefabricated buildings, the base was completed in 4 weeks.
In 1955, a young but experienced pilot named Lieutenant Commander Conrad Gustin was among the first R4D pilots to join the new VX-6 squadron supporting the IGY in Antarctica. Gus was born in 1922 in Spray, North Carolina, which is now part of Eden, North Carolina. He is currently living in Florida and will be 100 years old next year. Tom and I talked to him on the phone a few days ago. Growing up, he was obsessed with flying and studied aeronautical engineering in college at NC State. When World War II broke out, he joined the U.S. Navy and trained in Pensacola to be a pilot. Gus flew C-47 cargo planes, the forerunner of the R-4D, and flew medical evacuation missions into and out of Iwo Jima at the height of the World War II battles. After the war, when the IGY came along, Gus was well prepared as an experienced pilot and eager to join in the Antarctic adventure.
Lieutenant Commander Conrad Gus Shinn had been an R-4D pilot in World War II and in Operation High Jump, where he flew alongside Captain Trigger Hawks.
Deep freeze opened up, so I grabbed an airplane and went down to Washington and went in to see Captain Hawks. Hey, here I am. So I think Ed Ward in his memoirs said that I was the first guy chosen because Hawks knew me then.
The first flight from New Zealand to Antarctica was an eventful one. The plane that was following Gus's R-4D became lost.
Well, we had some electric compasses. That was a new thing back in that day. And we were about halfway to McMurdo. He came up on the radio that he was losing his compass and his unknown position. So I turned to the skipper and I said, "You hear this, skipper?" And he says, "Yeah." I said, "Well, I think I can go back and pick him up and bring him back. And I have enough fuel. I've saved my fuel." And he says, "It's your airplane." So it's an old trick. I'm sure a lot of pilots have used it in the old days, where if you have two aircraft, you just have them transmit on the frequency. And you pick it up with your loop.
Curtis's transmissions acted as a beacon, which Shinn's directional loop antenna could rotate and point to, guiding him back until they made a visual sighting. Curtis then trailed Shinn to McMurdo. Both planes were in the air more than 18 and a half hours. Had Shinn not led him to safety, Curtis's course would have taken him hundreds of miles off track, and he would have run out of fuel. He had barely enough to reach McMurdo.
Building a base at the geographic South Pole was a high priority for the Navy and the IGY. However, no one had ever landed an airplane at the South Pole, which is over 9,300 feet in altitude, with temperatures reaching minus 100 degrees and with unknown snow conditions. The risk was great, but the attempt to land had to be made as a first historic step towards building the first South Pole station. In the following video about the first landing at the South Pole, you will hear a discussion about firing JATO bottles. JATO bottles are jet-assisted takeoff bottles, which are small rocket motors attached to the airplane to give you more thrust to help you take off in difficult snow conditions.
Admiral Dufek instructed Captain Cordner to pick the best plane for the flight to the South Pole. Cordner chose the K. Sarah, commanded by Lieutenant Harvey Speed, a very capable and respected squadron pilot. However, Dufek wanted Trigger Hawks to pilot the flight, but Hawks had another recommendation.
The skipper, who was still my co-pilot, turned to me and said, "You're the South Pole pilot," just like that. It's a good day, good clear day. I had all the JATO for takeoff, so we could use it at South Pole. And I put on as much gasoline as I could because I didn't know what I would be faced with up there. And we just set up a landing and made a straight in approach to what we thought was South Pole.
Plane Captain John Strider followed procedure and exited the plane to put locking pins in the landing gear. He thus became the first American to set foot at the South Pole.
The Admiral and Captain Hawks got off, and my navigator, who had a camera, took the picture, the iconic picture. We really didn't think about being frozen in. We knew that we didn't have enough power to move.
He fired four JATO bombs, got the tail wheel broke loose, and then we started moving, and then fired four more, and then fired the other four. We got airborne at about, he said 60 knots, I said 58 knots. We finally got that big shoulder like this.
Off we went. Big deal.
Dufek saw that it was now possible to transport men and material to the South Pole and ordered the construction of the world's most southerly outpost. Navy Lieutenant Richard Bowers flew to the pole with a team of dogs and men aboard two R-4Ds to establish the first camp. C-124s dropped materials for the base by parachute. The 18th Air Force's 63rd Troop Carrier Wing flew 84 drop missions from McMurdo that season. 881 tons of cargo were delivered.
The IGY was a great success, and scientists wanted to extend their investigation of the Antarctic. However, an obstacle to cooperation remained: the territorial claims of various nations. A multinational group studied how to resolve this. Former US Ambassador Paul C. Daniels was brought out of retirement to lead this group. His genius led to a proposal to not disallow claims, but to suspend them under a treaty that would open Antarctica to any country wishing to conduct science there. Military presence would be limited to logistic support only. The result was the Antarctic Treaty, agreed to by the 12 original countries with bases in Antarctica in 1959. The treaty has survived as one of the outstanding diplomatic accomplishments of the 20th century and is now acceded to by 50 nations, representing 2/3 of the world's population, and become the world's largest scientific laboratory. With the signing of the treaty, the US joined other nations in continuing exploration and scientific investigation of Antarctica. The National Science Foundation was established to oversee the science programs for the US. The Navy continued to provide the support for science through what they designated as Operation Deep Freeze. Aviation was an essential part of that.
When I moved to North Carolina many years ago, my new friends would ask me what it was like to fly cargo planes for the US Navy in Antarctica. I made a YouTube video overview of my experiences to show my friends what it was like, and I will share that video with you now. Hello, my name is Robert Tuttle. I'm retired now, but in the early 1980s, I was a US Navy pilot with the call sign King Tut. I was also a polar aircraft commander that flew ski-equipped LC-130 cargo planes down in Antarctica. I served in Antarctic Development Squadron 6, which is also known as BXE-6. The squadron's unofficial nickname was the Puckered Penguins. I hope you will enjoy learning a little bit about flying on the vast continent of Antarctica that we all call the ice. BXE-6 flew two types of aircraft on the ice. The large 4-engine LC-130 Hercules aircraft that I flew was equipped with both wheels and skis. This picture shows a ski herc taken off from the South Pole. We also had UH-1N Huey helicopters in the squadron that operated near our base at McMurdo Station. All the pilots in the XE-6 wore emblematic sunglasses when we were flying because the bright sunlight reflecting off the snow made it hard to see the landing surface. The XE-6 air operations were a critical part of the Operation Deep Freeze. Our missions were flown to resupply U.S. Antarctic bases
and also support science expeditions that were conducted in numerous remote areas on the ice. This video shows the ski takeoff and landing from an established skiway, as well as a cargo pallet offload. Taking off and landing on the skis was a unique experience for me and was very challenging due to the rapidly changing snow conditions, especially at the remote science camps. The XE-6 twin-engine Huey helicopters operated out of the hangar in McMurdo. They had much shorter range than the LC-130s, but were able to deliver scientists and cargo in many important areas, including the dry valleys. McMurdo Station was the largest U.S. base on the ice and was located near the Ross Ice Shelf and also near an active volcano named Mount Erebus. Every winter, the ice would freeze around McMurdo and cut off access to the base. The U.S. Coast Guard icebreaker would have to come down at the beginning of each summer season and break open a channel for the cargo ship to deliver fuel, food, and supplies to allow the station to exist for another year. The weather at McMurdo was very unpredictable. The air was always very dry, so you needed to drink a lot of water to prevent dehydration. When the wind blew hard, the snow would reduce visibility to zero in McMurdo. When these storms occurred, you would just stay in your building. The weather down at the ice runway and the skiway was also unpredictable. When the winds blew the dry snow around, it was very difficult to do maintenance on the planes. The hard-working VXE-6 maintenance personnel had to do the servicing and repairs without any shelter, because we did not have any LC-130 hangars on the ice. If the weather got really bad, maintenance would be suspended and the missions would be delayed. Christchurch, New Zealand had a VXE-6 maintenance detachment that did major repairs and inspections on the LC-130s that could not be done on the ice. In August each year, several LC-130s flew very long round-trip missions from Christchurch, New Zealand to McMurdo Station and then back to Christchurch. These missions were called wind-fly flights, and the engines would never be shut down after we landed on the Williams Field Skiway. We would just offload the cargo and passengers and hot refuel so we could get back to New Zealand as quickly as possible. In September, we would go back down to the ice from Christchurch with most of the squadron personnel and then begin the resupply missions to all parts of the continent while living in McMurdo. We would not head home to California until February each year, so these were long deployments away from our families, and letters took a long time to get home. We flew a lot of resupply missions with cargo, fuel, and passengers from McMurdo to the South Pole during my 3 seasons on the ice. We also flew a lot of aviation fuel in the Bird Station, which was basically a refueling station for us later in the summer season. The continent covers an area that is larger than the entire area of the continental United States. The scenery as you fly around the continent was breathtaking, including massive glaciers, mountain ranges, and vast areas of ice and snow. I considered myself very fortunate to have been able to see the continent from the air. South Pole is very cold, very dry, very windy, and at a very high altitude, over 9,300 feet above sea level. VX-6 and VXE-6 flew many resupply missions to the South Pole during the 44 years the squadron operated on the ice. In addition, history was made twice. Admiral Byrd's crew did the first flyover of the South Pole in 1929, and VX-6 pilot Gustin made the first landing at the South Pole in 1956. Just about everyone that goes to Antarctica and gets the opportunity to go to the South Pole has to have their picture taken to prove that they were there. This is a picture of me walking through the dry snow at the ceremonial South Pole and standing on Observation Hill overlooking the Ross Ice Shelf and Skiway. In 2012, I was notified that a cape near McMurdo has been named after me, called Tuttle Point. So that is even better proof that I was there than the pictures. Lockheed LC-130 Ski Hercules was a very reliable airplane to fly. However, flying in Antarctica, taking off and landing on snow and ice covered surfaces was hard on the LC-130s, and sometimes things would break. The nose ski in particular took a lot of beatings, and sometimes it would malfunction, as in this video. Remote science camp missions were always the most challenging missions we flew, because you were landing in places no one had ever been before, and you were landing a very large, very heavy airplane on unknown snow conditions. We had many techniques to minimize the risks, such as surveillance missions to the area and a ski drag technique to test the snow before we landed. However, sometimes things would go terribly wrong. There were many accidents over the years due to weather, hidden crevasse fields, and loss of situational awareness due to the visual perception problems with landing in white landing areas and snow-covered terrain. The exploration of Antarctica has yielded many scientific discoveries, but as in any exploration effort, it has had a high cost on aircraft, but more importantly on the people, including the loss of members of the XE-6. The XE-6 delivered massive amounts of fuel, cargo, and many thousands of passengers over the 44 years of the squadron's existence. The puckered Penguins, later renamed the Ice Pirates, had a very long history of success on the ice. However, in 1999, the Antarctic resupply mission was transferred to the Air National Guard out of New York. They had flown LC-130s for years on the snow-covered areas of Greenland. I wish them the best and hope they stay safe as they continue the Operation Deep Freeze mission. This presentation is dedicated to my squadron mates in VX6 and VXE6, and all the brave men and women who have worked on the ice over the last century, from the United States and also from many other countries.
The ending clip from Ice Eagles provides a good summary for this presentation.
We were the pioneers beginning with Bird, and the Antarctica is category to the entire world.
I felt they were a classy group of individuals myself. I had great admiration for them.
I would love to go back one day, but it'd have to be at the end of the season when it's at least 2 degrees.
I certainly did things that a lot of marine aviators will never do.
We just went. And, that's great. When you go out without rules and if you're well trained up to that point, then you can learn quickly.
It was obvious that it was potentially hazardous, but it was exhilarating to go out. And I thought we had the best job going because we got to go everywhere and see everything. Most fun you can have and stay out of jail.
I hope we don't muck it up down there. It is, it's a laboratory, but it's just.
New junior enlisted guy, he steps off the airplane and he goes, first thing he says is, Christ, it's cold here. And the salty chief says, congratulations, you're an expert on Antarctica. Here's a shovel. Get to work.
All right, I guess we're ready for questions. Thank you.
All right. Well, I have to say that looks just fantastic, like how you just kind of explain that whole evolution in aviation, that's and it's so treacherous to work in those conditions. It's just mind-blowing. We had one viewer, David Brook, and he said, we had a Giotto bottle. I don't know what that is. Maybe you can explain what that is. on base at Haley Bay on the Waddell Sea coast, and it was used by the VX-6 Hercules C-130 that evacuated the base doctor after he broke his back. Maybe you know anything about that, and maybe you can kind of like elaborate on that.
Yeah. JADO bottles, basically, it's like I was saying, they are little rocket motors that you can attach to the back of the C-130. We had 8 of them, 4 on each side. And normally you would try to take off without firing the JADO bottles, at least because when I was there, it was a one-shot deal. When you shot the JADO bottles, you better be taking off because otherwise you were up the creek. And we used to leave JADO bottles at the science stations so that if we needed them, we could use them. But yeah, they were big rocket motors, and Tom was at the bases, so in the Ellsworth Mountains, so he could talk about that too.
Yeah, actually, at that point, I don't recall we ever, the LC-130s ever had to use JADO, but they certainly had it available. As to the Waddell Sea evacuation, I'm not familiar with that one, but that was done a number of times for medical emergencies. In fact, they have evacuated in the middle of winter, which is incredibly dangerous because of the temperatures. So yes, I'm sure that on that particular case, they might well have used JADO. And Rob, confirm if you will, I think those bottles have about 1,000 pounds of thrust, and they only last for 15 seconds or so.
Yeah, they're one-shot deals. They're 1,000 pounds times 8, so you have 8 of them, and yeah, they last 10 to 15 seconds, and they give you an extra kick, but you better be close to. You heard them talking about 60 knots. 60 knots was important to us too, because at 60 knots we would try to get the nose ski off the ground. Because if you could get the nose ski up above the layer of the snow, then you could pretty well accelerate up to takeoff speed. Yeah, we carried the JADO bottles, especially to the new science stations, the first time there, and we we had them ready, but we had a lot of other tricks we used before we used the JADO bottles. We would taxi up and down and try and pack the snow down, try to figure out where the wind was. And yeah, it was really tricky with those crevasse fields. You really had to watch out. So we tried to get the scientists where they wanted to go, but sometimes you couldn't get them exactly where they wanted to go. You had to get them into a safe place near where they wanted to go.
Yeah, that was also one of the questions that we had, is like, how many stations are there basically? And are there like certain stations that are just for like refill, or certain stations just like for research and maybe a specific type of research? Or is it just,
Yeah, you can take that one, Tom.
At present day, there are 3 main stations that the U.S. supports in Antarctica. McMurdo, of course, is still there. South Pole, which rebuilt the station for the 3rd time, started in 2008. I'm sorry, it opened in 2008. So they have a newer station now. And Palmer Station, which was established in the late 60s, and that's up on the Antarctic Peninsula. Bird Station is used temporarily in the summertime, the Antarctic summer, and again for basically fuel resupply, as it was when Rob was down there.
Yeah, it's basically our gas station. Bird is our gas station.
Gotcha.
So research is being conducted in all the 3 main stations, and as far as I know, there's nothing science-wise that's going on at Bird right now.
Right.
And that's closed, of course, during the winter.
Right. So not all the stations are open year-round, I presume.
The 3 main bases are open.
Oh, they are.
Yeah, okay. We do supply, or we do maintain those stations during the winter.
Yeah, somebody was also asking, so you were kind of like showing off a few of the wildlife that you envisioned there, that you saw there. And so there is also an emperor penguin. Did you see any of these? And how big do you think? I mean, I've heard that they're pretty big.
Yeah.
Rob, I'm sure you saw a few too.
Yeah, we see them. You know, they actually wandered across the skiway once in a while. That the emperors, they're I don't know, 3 or 4 feet. They're pretty big animals. We didn't want to run them over. We had to be careful. You know, when they were out there, we didn't want to run them over when we were taking off or landing. So, but they weren't at the skiway very often. But our helicopters used to fly to the penguin rookeries with scientists a lot in the in the various areas around McMurdo, because there's several rookeries, you know, with the Delhi penguins and emperor penguins.
Right.
You know, one of the largest emperor rookeries is on Ross Island. It's the opposite side of the island from where McMurdo is. Mm-hmm. So the helicopter is the only way you can get over there, but it's an enormous rookery for the emperors. They're amazing animals.
Yeah, I can imagine. I mean, just I understand that it's pretty cold out there, but just being there must be just like a very special feeling, you know, being able to see all that wildlife. So one of the people in your video was also saying something about, you know, we hope that we don't mess it up right there because it is a laboratory. And one of the questions that I had is like, well, it is shrinking. So is that affecting the bases, with the position of the bases right now? Are you going to have to eventually move it, or?
By shrinking, I imagine that you meant the ice cap is shrinking.
Yes, sorry.
Yeah. Yeah, that's one of the big topics of research right now, is just what's happening with the ice cap. And there's some real implications, obviously, for the rest of the world. If the Antarctic ice cap collapses, at least the west side, that's 90% of the world's ice right there. Mm-hmm. And that, if it was very sudden, which is a 10-foot rise in sea level. So right now, but they are, except for the South Pole Station along the coast. So a rising sea level could eventually jeopardize the location of those bases. But that's going to be a few years down the road. Mm-hmm. Yeah. In the meantime, there's a lot going on, and every year is getting more intense as far as the scientific research.
Yeah, so you're starting to collect more and more data as well. And then my question also was like, those research facilities or the bases, are they constantly being maintained and rebuilt? And that must also kind of like, and there's like a lot of planning that probably goes with that as well, right?
Yeah, the South Pole, like Tom mentioned earlier, the South Pole was rebuilt not too long ago. When I was there, you know, it was like we had a dome over the South Pole, but you would think the dome covered, you know, buildings, but when you went under the dome, it was just a bunch of modules that were hooked together, almost like freezer compartments. Mm-hmm. And, you know, the dome on top was basically protecting them from the wind, but as the snow built up, eventually it was getting higher and higher, and you were having to go way down under the dome to get to the, you know, the module buildings. And eventually they took that dome apart, and I think it's in the museum at the CB Museum out in California at the Port Hueneme, because the CB's built, and Tom touched this in his section, the CB's, they did a lot of work down there. Like every year that winter fly-in that I was talking about in my video, that's basically what we were doing, was we were bringing the CB's down to McMurdo so they could go out and build us an ice runway on the temporary ice shelf, because we could land heavier and take off heavier on the ice runway than we could on the skis. So the Seabees did a lot of work, and I don't know if people know what the Seabees are, but they're the Navy's construction battalion. They're like our builders. And Tom touched on that in his presentation too.
Right. Well, this was a really wonderful presentation. Thank you so much for doing this for us. And I also want to thank our viewers for joining us today. We do have a few more programs left today, and we're going to put a little link for those programs in the chat. So I also want to thank our sponsors, the North Carolina Science Festival and Biogen Foundation, and also our Friends of the Museum members who support us every single day. And because of their support, events like this are possible. So thank you again, Tom and Robert, for your wonderful presentation. I really enjoyed it. I learned a lot. And I can't even imagine, all the sacrifices that you both had to make on numerous journeys up there. So not only for yourself, but also probably for your families. So thank you so much. And if you want to say something to your viewers, then we can.
I'd just like to say a big hello to Gus Shinn if he happens to be watching.
Hi, Gus. I hope he is.
I hope he is too. Well,
again, that was one of the reasons we did this. Is Gus is from North Carolina, and we want people to know that he made the first landing at the South Pole, which was a very historic accomplishment.
Right. So it's really in honor of Gus as well. Well, thank you all so much, and I hope you have a wonderful rest of your day. Thank you. Bye.
Thank you.